Okay, here we are, Chapter 1, Lesson 2, Writing Expressions. This is really an assignment that helps us understand story problems better. We break word phrases apart so that we understand which ones are for addition, which ones are for subtraction, which ones are for multiplication, and which ones are for division. And you read a story problem, sometimes it's hard to tell. Sometimes it's easy to see. It could use the word plus. That obviously is addition. Or it could say added to. You might find words like the sum of. And we need to understand that sum is an addition type of sentence or phrase. Subtraction phrases, things like decreased by, or fewer than. There are others. You have to just kind of get used to these ones. And multiplication, the product of. Actually, just the word of usually means times. I know we have the word of over here, but in general, like 3% of a number means times. So it's one to keep in mind. The product of is for multiplication, and just a couple of ones for division. And the big one you need to know is quotient. Okay, so those are kind of the standards, and you have to figure out what to do with them. If it says something like 8 fewer than 21, you have to understand that there's an order. It really means that you start with 21 and you subtract 8 from that number. 8 fewer than 21, you're saying that there are 8 fewer than something. So the 21 was already there and you had to take 8 away from it. Some students might try to do 8 minus 21, and that is actually incorrect. You have to very carefully listen to the language of the words and make sure that you pay attention. It's especially important with subtraction and division because it's not the same. With addition, 3 plus 5 is the same as 5 plus 3. And with multiplication, 3 times 5 is the same as 5 times 3. But with subtraction and division, you can tell that the answer is not the same when you flip the addends or the dividends or whatever. All right, let's look forward in the book a little bit. If they use algebra, they might say 14 more than a number, and the number could be x plus 14, but if it doesn't tell us, it just says 14 more than a number, you might use an x. We don't know for sure what this is, so we don't actually have to come up with an answer. We just have to interpret this phrase into an algebraic expression. This is an expression, this is not an equation. It becomes an equation when you put an equal sign in there and you have a balanced equation if it's true. Alright, so x plus 14 equals 16. If we do something like this, we can see that x must be equal to 2 because 2 plus 14 is equal to 16. But over here we just have an expression. And I think we've already talked about those, but it could have been another class. Expression, this is an equation. And I like to think of it having an equal sign, and it kind of goes together, equal and equation. An expression is just half of an equation, one side of the equal sign. Okay. Any number minus 75 will be another example that we could look at. Any number minus 75. And we start with any number, and we don't know what it is. Oh, any number y. The book actually gives you this one. Any number y minus 75. any number, maybe if I change colors it'll look a little better. Any number y minus 75. Okay? And if they give you the number, then it's best to use the number they give you, y minus 75. Any number y minus 75. It's an expression. Good. You're going to have to do some on your own. Notice that they give you a real-life application on page 11. Plant a cypress tree that is 10 inches tall. It increases by 15 inches every year. So it starts at 10 and it adds 15 every year. So this would be 0. The first year, the 0 year, at the end of the first year, it would add 15. At the end of the second year, it would add 15. At the end of the third year, it would add 15. And we can actually, if we want to, we can start writing an equation. Notice that this is just 15 over and over again. If we add over and over again, we really should multiply. And notice that when we have 3 15s, it is the third year. When we have 2 15s, it's the second year. And when we only have 1 15, it's the first year. So we could write an equation for the number of the height of a tree. We could say h could equal the height equals the 10 inches that it started with plus 15 inches times the number of years. We could put a y in for the years. So 15 times 0 is 0 plus 10 is equal to the 10 inches it is when we get it. 15 times 1 is equal to 15 plus 10 would be 25 after 1 year. And we could actually put this into a chart with the years being first and the height being what the output is. We have an input and an output, and for 0 we got 10, remember? And for the first year is 15 times 1 plus 10 is 25. And if we were to just throw in another one, like say how tall would it be after 5 years? Well, 15 times 5, you might need a calculator to do that, or do it on the side. 15 times 5, that might be the best way. 5 times 5 is to carry the 2, plus 2 is 75. So 15 years will be 75 plus the 10, that actually is 85. So pretty cool how that works. They show you a great graph on page 11, and you can see that the graph makes a straight line. And they don't actually have 5 years listed in there. They only have 4 years listed in there. But you can see that we probably have that all worked out. Let's see if there's anything else in this that you need to be able to do. I think everything else is self-explanatory and you can probably handle it. Good job.